Ocean acidification is an important issue through the world's marine life. The normal pH of the ocean is 8.2.
The ocean's buffering system makes seawater more resistant to changes in pH levels than freshwater. Carbonate ions within the sea tie up excess hydrogen ions when a base is added, regulating the ocean's pH levels.
However, an excess amount of hydrogen ions released from the absorbed carbon dioxide offsets the balance of the buffering system and causes the ocean to become more acidic. This excess carbon dioxide is sourcing from carbon dioxide emissions and pollutants released by humans into the air.
Sea creatures are suffering because of the increased acidity of their habitats. By raising the pH levels of the ocean, the excess carbon dioxide is endangering the lives of marine organisms, who use carbonate ions with the sea to build their shells and skeletons.
However, excess hydrogen ions found in acidic waters take away many of these carbonate ions. If ocean waters continue to become even more acidic, these shells and skeletons can actually dissolve.
Our experiment stimulated how our oceans are affected by carbon dioxide. We came up with our control group of freshwater and our experimental group of saltwater. We asked how long after the addition of carbon dioxide would each type of water change pH levels. Our independent variable was type of water and our dependent variable was the amount of time it took for its pH levels to change. We hypothesized that if we added carbon dioxide to both the fresh and salt water, then the fresh water would change its pH level faster because the salt water's buffering system makes seawater more resistant to changes in pH levels.
We then asked what effect each type of water would have on the addition of calcium and carbonate. This is what makes up marine animal shells and skeletons, and we used chalk to represent this in our experiment. Our independent variable was type of water, and our dependent variable was how dissolved the chalk was at the end of the experiment. We hypothesized that if we added calcium carbonate to both fresh and salt water, the seawater would dissolve it better than the fresh water because of its higher acidity.
We began with 2 test tubes, one of 10 milliliters of salt water and one of 10 milliliters of fresh water. We added 5 drops of universal indicator into each test tube to test the pH levels throughout the experiment. At the beginning of the experiment, the fresh water had a pH level of about 7, while the salt water measured it at about an 8. This was close to the pH level of actual oceans. However, a difference could be present based on human error reading the levels and colors. Other factors that may play a part in pH level in the ocean were not existent in our test tube as well.
We then used a straw to breathe carbon dioxide into each type of water. We recorded the time it took for each to change pH level. It took the salt water approximately 9.36 seconds to change pH level, while it took the fresh water only 5.42 seconds. Based on these results, we proved our hypothesis that if we added carbon dioxide to both the fresh and salt water, then the fresh water would change its pH level faster because the salt water's buffering system makes seawater more resistant to change in pH levels.
We then added the chalk or calcium carbonate to each type of water. We found that the salt water did a better job dissolving the calcium carbonate than the fresh water. Based on these results, we proved our hypothesis that if we added calcium carbonate to both fresh and salt water, the seawater would dissolve it better than the fresh water because of salt water's higher acidity.
After analyzing our evidence, we wanted to compare our results with 2 other groups.
So in your group, which pH changed faster, the distilled water or the salt water?
The distilled water changed faster because the salt water has a buffering system.
Which test tube dissolved the calcium carbonate better, the distilled or the salt?
The salty water.
So Tommy, which test tube, the salt water or the distilled water, changed pH faster?
We had distilled water change faster.
And which test tube, distilled or salt, dissolved the calcium carbonate better?
We got salt.
Thanks.
We found that the other group's results were similar to ours. We also were able to find slight differences, proving that human error may be played a part in this experiment.
After completing the experiment, our group gained a better understanding of how our human world on land is contributing to the ocean. Just as the carbon dioxide from our breath was able to change the pH levels of the water within the test tube, our population's excess carbon dioxide can change the pH levels on the ocean. Obviously, there is a greater impact in the latter as marine life depends on this acidic balance. Through our experiment, we were able to see how this acidity could impact chalk, which contains the same chemical makeup as marine animal shells and skeletons.
It is obvious that ocean acidification is a real problem within the world today. Humans continue to play a major role in this issue and must do their best to contribute to possible solutions.